So some of you may know me from past conferences. I was working with a lot of interactive performances and audio stuff. This is not related to audio at all. This is not to audio, not to music. It's related to audio, but not to music. So this is some work I've been doing as a professional web developer, front-end developer, before becoming full-time professor at my university. So now I'm not working in coding anymore, but I'm still doing like writing papers and stuff. I may not take credit for the work because like the work is basically an idea of Rafael Diniz. He's there on Zoom and he may ask the technical issues about codecs and all the technology behind. I'm gonna talk more about motivation. And it's like a work that is founded by this Rhizomatica Foundation, who is ruled by Peter Bloom. It's like, I think is United States based. And Rhizomatica began in 2009, developing autonomous cell phone network for the Oaxaca people. They were providing also high fidelity, high frequency radio telecommunication for the autonomous zone in Oaxaca. And they are trying to build like infrastructure for people that doesn't have access for commercial systems, or they are dealing like facing with oppressive regimes or censorship and all this kind of stuff. So this is a map about share of population using the internet in 2019. So you can see there's a clearly correspondence with economic power and access to that. And even those places that looks like homogeneous zones, they are not. So you have like spots where there are lots of people with access and spots that are known. And there are actually nearly 4 billion people has poor or no access to internet in the world. It's quite a lot of people, and we know that having power of communication is also like having power of for everything, like to organize politics, to have access to health and to education and everything. So this mission of Rhizomatica is like to increase access and participation to telecommunication for these people, and also to so they can have like self-build and independent infrastructure. So they did that in Mexico. They had these autonomous cell phone networks that were places that the telecommunication industry doesn't want to do because they don't have economic power and even to be commercially viable. And they realized they had like, even in zones that there are no telephone access, people who does have smartphones, because they use as cameras, they use as lighters, they use as player, radio player, music player, and everything. This is like a small print screen of, okay, just this is small one slide first. So they are creating like open source technologies and to help that, and also advocating for fair band use of high frequency and organizing strategies like dealing with government and everything. Yeah, this is a small print screen that I took from Google Earth, so you can see like this is a small portion of the Amazon forest, and you can clearly see that and that. The difference of these two areas, they are basically indigenous territory. These ones are the indigenous territories, and these ones like all white men could take. They are taking now, right now, what they didn't took in the like 5 centuries. Um, yeah, and this is important. Like maybe we think like some kind of altruism, but it's not. Once I talked to indigenous leadership, and they ask her, "Oh, are you afraid of being extinct? Like if the indigenous got extinct?" I say, "No, we are not. We are like living like 10,000 years in the forests like this, but you should be, because if we die, that means there are no forests anymore, and you will be dead. Um, yeah, so that's the thing. So the basic idea of Hermes is enable transmission digital data to high frequency transceiver for they have like very long links because the distance are quite big, like maybe like hundreds of kilometers. They don't have even electric power or cables or you see like optic fibers or stuff like that. So the first thing was serving the Amazon rainforest. Yes, in this like being a long time project, they started like by serving hi-fi radio first, and then they started to try data communication in 2015. This Fonia Jurioá project that Rafael was working in the University of Brasilia, and also they in 2020 they do like with Cara Solar a partnership to do on the Ecuador to install the Charamensa territory. And it basically consists in small stations. They have like local connectivity. So we have a box. It creates a local Wi-Fi network without internet. And they can be connected to solar panels. They have a telescope mask to put the antenna. And you can have also global connection through shortwave radio. That it can goes like far more than 1,000 kilometers far, but yeah. So the Hermes system consists, but we are like, these are quite changing a lot, like in the last months, like while I was writing the paper, they were implementing the web audio stuff, and also they are building new modems and stuff, so everything is changing a lot, but basically they have a Hermes central station that it's connected at some point to the internet. And we have local stations that could be as far as 1,000 kilometers, I think. We think like 100, 200, 600 kilometers, wherever. And these these stations communicate to each other through an agency by this central station. So the central station calls them and ask them if they have something to send and to receive, and like orchestrates the communication between them. So yeah, in 2021, I started to work with them to do this new interface. We are using Angular. We installed 10 systems in Rondônia, 10 stations, and it means one gateway station and 10 or 9 other around. And we also had a system upgrades for the Ashwar territory before. So this is a gateway station installed just like this year. This is a local station. This is a kind of this antenna on Amazon. Yeah, so basically the Hermes box is they have like open source technology. So we have a hi-fi long range radio, sorry, and like it has the internet. And now we have this kind of design this message system that we can also do an emergency call. If you don't have like the gateway schedule, you can do like press a button, say send now, so people can like in emergency people. Okay. The hardware is a computer with Debian Linux, an Arduino, and a BTX radio. It's been replaced to Hermes Light radio. And we also had like custom circuits for radio protection and also for power amplifying. And we have like basically 2 types of communication. So public messages they can send from one station to other. They can have audio, and also they are encrypted or something. They can be encrypted. And also we have private communication through email. So anybody who has access to this box can create an email account, and this email account can communicate all over internet. And we have also the web interface for administrative and everything. So this So it doesn't work on the internet. The system itself, it uses UUCP, that's Unix to Unix copy transfer protocol. That is something that was made before the TCP/IP protocol because I think it's lighter. Because at now, like the first Hermes system we installed and tested, were having like 20 bytes per second of data transfer. So it was like it's very, very slow. But for people that doesn't have any kind of communication, this is like awesome. So this is the web interface of this version. So we have this like public messages list, and we could compose messages. So the stations, they can like be configured so everybody can send, or maybe only the administrators can send, and maybe just logging users are registered and something. So have this kind of configurations that can change by community to community. They also can install like a Delta Chat, which is an app. So we have like the files are ready for download offline, so people can install them on the phone. They're not synchronous because it depends on the schedule for by defining that they also can be defined by the web interface for how many times it will change transmission by a day. And now we have also this web audio interface for using the radio. So people can turn on and access the radio, hi-fi radio, like regular radio, through the phones. So that's something, because this all of that before was asynchronous, but sometimes people just need to say, okay, let's go, let's talk now. They can turn on, okay, they can control the configuration, the frequency of the radio, and then just talk something, remembering that communication over radio is not secure because everybody can listen. But yeah, this is a still simple interface, like what just was developed last month, so it's going to be updated. There are lots of things to do in the system because we have a very small team of group of people. We have this is interface for the radio configuration. We can send like have the GPS calibration. We can change the frequency, change the modulation of the amplitude or something. This is quite of a brutalist design approach that I like it. I quite like it. Yes, and we have like some challenges, lots of challenges. We don't have too many resources. The main problem for now is to having a manufacture that, because we are like there's only one guy that is doing all the circuits and doing the boxes and dealing with the boxes. So we would like to have like this to be locally manufactured in Amazon. There's some all issues to transport that because it can like even they might be illegal at some places. That's not all places that you can use radio and technologies. And we are also working in different areas, like to make a new modem that could better orchestrate the process between the stations, maybe change frequency automatically, so we have like multi-channel usage, or have like more aggregation of channels so we can send more data and this kind of stuff, like to create this super node so we can have more information thing. But this is like we just got installed, like they just got installed. There are lots of issues currently, lots of issues with the interface and thing. But it's something that really like could help to protect the forest, because like this is what I said, like we depend on that as well. So I will have, I don't know if I have more time, because the Rafael is there on Zoom. I don't know if he can talk a bit. Are you there, Rafael?
We are running into the questions, but
yeah, but maybe if you have some questions, maybe he is the guy for answer. He's computer science as well.
Maybe we can thank Ariane already. And hello.
Hello, hello. Just testing the audio. Can you hear me?
Yes.
Perfect. So let's go to the questions, or should I say some words? What do you think?
Well, maybe we have you have two phrases for the introduction, and
Okay.
we'll prepare the questions.
Okay. But I mean, just clarifying one small mistake. Please don't use hi-fi word. It's not high fidelity. It's far from it. It's high frequency radio. That's a frequency band that is by ITU between 3 megahertz and 30 megahertz. Electromagnetic waves, not audio waves. And yeah, the only web audio contribution that we made is really uh, allow users to use the analog amplitude modulated radio over the cell phones, so they can really change frequency and press the push to talk button of the radio in the phone and really be able to talk in analog over hundreds of kilometers using the phones or a computer. And this was a request by the indigenous communities. And in the beginning, we didn't thought about it. We just are exchanging email asynchronously over in chat, very slowly, but it goes through. And then they asked, no, we also want to be compatible with analog radio. And this was the main motivation that we developed this web audio interface. And yeah, now learning a bit about it, we got excited to do more. And I think I'll not extend much about my talk, and then open for questions. And yeah, thank you very much. Thank you, Ariane.
Sorry for
not being together with you.
sorry for the mistakes. I am a bit like, okay, that's nothing working.
Yes, thank you. Other
And
questions?
thank you very much for making me like work on that even a bit. But
Thank you very much.
Other questions about the project? Yes, they are. I'm quicker.
Hi. Sorry, I'm not sure if I missed this, but I was thinking about the relations between politics and the allocation of the radio frequency spectrum. So you mentioned the whole band, but I'm imagining how do they send messages and who listens and who speaks, and how do they distribute the bands between different people? How do you distribute the spectrum?
The spectrum is allocated by each country. There is a regulation by ITU. There are many sub-bands in the HF band. We use a licensed band. Ham radio people use other bands also in HF. And I mean, we have two types of message. Let's say the asynchronous digital ones, that's secure, that you carry email. All the stations in the forest send emails to the station in the city where there is internet that routes the email through the public internet. And voice messages, I mean, analog SSB radio is the most used communication media in the Amazon rainforest by indigenous communities. It's just analog radio, SSB, single sideband, amplitude modulated radio that anyone can tune and listen. And
yeah. So what I mean is there will be is it like one single channel, or there's a spectrum inside the allocated spectrum? There will be like different frequencies, and one can emit at some frequency, and one can synchronize that frequency, I guess.
Right.
So how do you organize this?
For each network, we have one channel right now. You asked, I mean, the last community, you asked two channels, but usually it's just one channel we use each time. The center station stays in this channel, and all the other stations stays in the same channel. So it's always a peer-to-peer communication. The center station connects to the station 1, then to station 2, then station 3, then station 4, and ahead. And so it's just one channel. Of course, for voice, it's not like this. For voice, people just get their hands in the dial and turn the dial and choose whatever frequency they want. This is not really perfectly legal, but I mean, there is no other communication medium in there, so okay.
Yeah, thank you very much. This is, I mean, really, really great. As decentralized autonomous system, it's really, I imagine it can be really hard to make this in place. I wonder how, on the human part, how do you organize with the communities the maintenance of the systems and maybe the feedback through the communities so that you can make things happen in the future and make a good evolution of the overall system?
Right. We have Rhizomedica, that's our US-based NGO that funds the development of this project. And in the ground, in the Amazon rainforest, we work with many NGOs, like WWF, in Brazil, there is Instituto Socioambiental, and there is other NGOs working with us right now, like OPAN. And yeah, I mean, communities need help for training and for the solar panels, batteries, and the radios themselves. The most important of this system is that there is no monthly payment, right? There's just investment on the equipment and maintenance of the equipment that's different than satellite connection. It's expensive for them to pay monthly payments. So this is the cheapest of all options. And of course, there is expenses in maintaining it, but the funds, let's say, less long. And we try to make the equipment very modular, like the radio is a board, and then there is a computer in another board. So if one thing breaks, you just change one board and not the whole equipment is fucked up. So yeah, I mean, things are modular, and this radio, for example, is $100, so it's not that expensive. And for example, if you pay 1 year satellite connection, you can install 10 Hermes systems, and yeah, it's cheaper. It's not perfect yet, but it's better than what is available, I think. And we're advancing.
I guess at this point, the timing of the session joyfully and completely went out of control. So if you have any more questions, if not, thank you very much.
Thank you. Thank you, Juba.